No. Yes. So last class we finished. Oh, just a minute. Those who are online, are you able to hear me, right?
Yes, sir.
Okay. So last class we discussed how to solve inverse based problems. Right? Can someone tell me what are the steps to be followed? So when will you say inverse for a function will exist? Sorry? When it is both 1 to 1 and on to, what condition is supposed to get satisfied? So function f is mapped from x to y, then the inverse of this function will be defined from y to x. That is the domain and the codomain will get swapped, right? So that f circle g is equal to g circle f will give you a function I. They'll give you identity function ix or iy, that's a different story. But to summarize it, they're going to give you an identity function. What do you mean by identity function? Y is equal to x. Correct? So when you do the composite of these two functions, it gives you I. So what are the steps that you will follow to find the inverse? So what will you do? So the given function, you will consider it as y. Then you will find x in terms of y. Then what will you do? You will find for what values of y there is, finite value of x generated. Right? If it is existing and this value is exactly equal to codomain, then what can you say? That is the inverse. So there are two things that are getting satisfied. If at all you are able to prove that the codomain is equal to range, one thing is you are proving that it is an onto function. Secondly, you are also finding the inverse of it. Okay. So having all these things in mind, let's see the actual application of why we studied inverse trigonometric function. Let's see if things are getting simplified. Okay. Like I told you in the previous class, for you to understand this chapter, you need to know a little bit of basics from your 11th grade. That is, you need to know the domain and range of different trigonometric functions. It is then you can find the inverses of it. Right? So, listen. So, what are the 6 trigonometric functions that we know? So, you have sin x, cos x, tan x, cosecant x, secant x, and cotangent x. Right? So, for all these functions, you guys know the domain and range clearly. Do you know that? Okay. So, if I take sine function, okay. So I want to ask this question. If I take sin x, okay, then what is the domain of this? If I call this as y, x belongs to what? X belongs to real numbers and y belongs to what? So that is the range, right? What is the range of this? What is the meaning of range? So you have the values which are existing between -1 to 1. So you take any real number and substitute it in the place of sign. The maximum value you can get along y direction is 1, and the minimum value you can get is -1. So this is what theory tells us, right? So maybe in your lower grade you would have learned the angles for 0 to 90 degrees, but the angles can exist from -infinity to +infinity, right? When that is a scenario, then how is the graph for this going to look like? So can I say this is how the graph is going to look like? So it keeps on going, right? So what value is this? This is 0, 1. And what value is this? 0, -1. So what value is this? It is pi by 2. And what value is this? Minus pi by 2, etc. Right. So this is all about what function? Sine function. Now what are the chapters name? Inverse trigonometry. So my job is to find the inverse of this sine and tell. But before that, I know the fact that inverse will exist only for functions which are 1 to 1 and onto. So in the previous chapter, I explained one concept. Remember? So how will you graphically prove that a given function is 1 to 1? So if you draw a horizontal line, and if that horizontal line is cutting the curve at more than one point, it is a many-to-one function. If not, it is a one-to-one function. Is this a one-to-one or many? It's a many-to-one because pi by 2 is giving you 1. 3 pi by 2, leave it. Then what about this? 5 pi by 2 is giving you a 1. So if you write the general solution, what will you get? Pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2. It keeps on going. All those values will generate 1. So many values from the domain are mapped to the same value 1. So it's a many-to-one function. Now, is it an onto function in the second case? How are you saying? So for me to call it as onto or not, I need to define the question properly. So I don't know the codomain. So the function is sin x accepted, but where is the function defined from? Just a minute. So where is the function defined from? That is the question. If it is mapped from real numbers to real numbers, this is a one-to-one function. This is an onto function. It is not. So for it to become an onto function, range or another? It's not range. Codomain should be equal to range. So just a minute, let it get charged. Just a minute. How many of you joined only today? Me? Karthik. Tarush. Okay. Tarush Bala. Harshini. Your name? Dinesh. Okay. So have you learned relations and functions before this? No, right? So it's like a new language to you guys. But okay. Just with me for one day. You can go through the videos and try to come. If you have any doubt, reach out to me. Right? Shall we proceed? Now, what I'm asking is, so to make it an onto function, see, if suppose the function is defined like this, R to R. So for real values, yes, it is understood that it is definitely not a one-to-one function. That is gone. For onto function, I need to start looking at the codomain. So when I started looking at the codomain, it is telling me it is still not a non-to function. So what are we supposed to do to make it a one-to-one function first? So yes, listen to my question carefully. Now I will be able to define, see, listen to this carefully. I have the function called sin x. I'll be able to define the inverse for it only on the day this function becomes a one-to-one and onto simultaneously. So what I'm going to do here is, I want to make it as a one-to-one function. How can I do that? Just a minute. Yeah. 1 minute. Got logged off. Guys, those who are online, you're able to hear me? Are you able to see the screen?
Yes, sir.
Those who are on, yeah. Sorry, I had some network issue. Yeah, what were you saying? So domain to be restricted to minus pi by 2 to plus pi by 2. If I'm able to restrict it, then what will happen? See here, if I restrict the domain from minus pi by 2 to plus pi by 2, then this is going to be the graph. Correct? Now, in this scenario, is it a one-to-one function? Yes. Now, you can ask me a question. Why didn't I take it from 3 pi by 2 to 5 pi by 2? One of the reasons is you need to do this at the starting point of the function. Right? So, where is the basic value lying? Somewhere around 0 is where we need to. That is why I took minus pi by 2 to 5 by 2. So, is this point clear? So, this is minus pi by 2. And this value becomes plus pi by 2. Because we are taking somewhere closer. We are seeing where it becomes one-to-one for the first time. When I say for the first time, generally with what value will you start? 0. That is why I'm saying nearby 0. right? But you can ask me 3 pi by 2 to 5 pi by 2 also it is a one-to-one function. Similarly, from pi by 2 to 3 pi by 2 also it's a one-to-one function. See, even this is a one-to-one function. Accepted? Correct, Ada? Pi by 2, 3 pi by 2. See, for you to understand what is a one-to-one function, right? If you just draw a line parallel to x-axis, it should cut the curve only at one point. In the previous case, what happened? If I draw a line parallel to x-axis, it was cutting the curve at more than 1 point. That is why it was not one-to-one. So I'm trying to make it a one-to-one function. So I'm trying to restrict the domain to minus pi by 2 to pi by 2. Now the question is, function initially was mapped from where to where? R to R. Now I restricted the domain from where to where? Minus pi by 2 to plus pi by 2, both included. Now my domain tells me that this function has changed into a one-to-one function. Now what change should I do to the codomain to make it an onto function? Minus 1 to 1. So I need to restrict the range to minus 1 to 1. Now I can say this function mapped from minus pi by 2 to pi by 2 to minus 1 to 1, sin x is a 1 to 1 and on. Now you can find the inverse for it. So this is the first step that we need to achieve. Okay, this is the one thing, this is the only thing I'm going to teach you in detail. For other functions, you have to think and tell me. If there is any doubt, get it clarified. Clear, Ada? Purida? Arshida, Vaishnavi, all clear? Sandhya, clear? Manakma? Clear, right? Okay. Niranjan, clear? Good. Nitish? Right. So, if f is a function mapped from minus pi by 2 to pi by 2 to minus 1 to 1 is a 1 to 1 and onto function, it will definitely have an inverse. Then, where will the inverse of this function be defined from? Where will the... So, it will be defined from minus 1 to 1 to minus pi by 2 to pi by 2. So, what is the meaning of this? In the previous case, for sin x is equal to y is there. No, try to listen to this carefully. Sin x is equal to y is there. No, if you give the input values as angles, the output value will come out as a number somewhere between minus 1 to 1, right? Whereas in the case of f inverse, you will try to give the input as numbers and the output will come out as angles. So inverse trigonometry function has another name called as arc functions. Okay, so some books refer to it. Why they call it as arc is because arc is the one which will define the angle. So that word we will not use it here. We will use inverse trigonometric function, right? Similarly, if I have a function f mapped from R to R, y is equal to cos x. Okay, I'll give you a minute time. Think and tell me whether it is a one-to-one and onto function or not. If it is yes, well and good. If it is not, restrict the domain and range at time. Try it out. Even if you make a mistake, no problem. Try it out. Is it one-to-one and onto? It's not. So how is the graph going to look like? So starting at x is equal to 0, what will be the value of y? 1. It will come here. Then what will happen in this scenario? It will go down. It will keep traveling like this. Is that clear? So what is this value? minus pi by 2 and this value is pi by 2 and this value is, sorry, this value is pi and this value is going to be 3 pi by 2 and this value is again going to be 2 pi. Any doubt in this? Clear, right? This is a basic of trigonometric function. Now I am able to clearly see if I draw a horizontal line, it is not going to be 1 to 1. So first, to make it a 1 to 1 function, I need to restrict the domain. So what is the restriction we can create? You can create it from 0 to pi, because 0 to pi, if I am able to see, the graph is first decreasing and it is going like this. Right? So for f map from 0 to pi, right, what will be the corresponding output values you are going to get? Right. If I do this kind of a restriction, then I can say that this function is a 1-to-1 function and onto. That is, it's bijective and it will have an inverse. So what will be the inverse of this function? Minus 1-to-1 to 0. Clear? So this is what happens. Similarly, take some time. Do for tan, cosecant, cot. Try them. Okay. So if you don't remember the graphs, right, you can take the help from textbook. But try to understand and do it. If there is any doubt, let me know. So for all functions, it is mapped from real numbers to real numbers only. So tan x is there, no. So tan x, if I call it as a function f, then that f is mapped from where to where? Can you substitute all real numbers for tan x? Domain another. What is the meaning of domain? The input values that you give so that you get a finite output. I repeat it, listen to this carefully. The input values are what are called as domain. If you give that input values, what should be the output value? It should be a finite value, right? So is there a place where tan will generate an infinite value? Where? Right. So it is 90, correct? This is only 90. You see, pi by 2, 3 pi by 2, 5 pi by 2. Similarly with the negative values as well. So f is a function mapped from real numbers except where? Except 2n plus 1 pi by 2, where n belongs to what? Where n belongs to integer set 2. This is a domain. Then what is the range? That is minus infinity to infinity. That is r. Minus infinity to infinity, or r means the same. Okay. So if this is going to be the scenario, then how is the graph going to look like? So it will look something like this, correct? See, this graph, I'm assuming you would have seen it last year. Have you seen it? Right? So this value is 0, this value is pi, this value is pi by 2, this value is 3 pi by 2, it keeps on going, correct? Now, you're able to see at pi by 2 what is happening. There is a break. On the left of pi by 2, the graph is going up. On the right of pi by 2, the graph is going down. So that's called point of discontinuity. Okay. About that, we'll learn later. But the question is it a 1-to-1 function or not? In the given domain, is it a 1-to-1 function? Draw a horizontal line. What is happening? It is cutting the curve at more than 1 point. So it is not a 1-to-1 function. So to make it a 1-to-1 function, what are the restrictions you can create on the domain? So where is it appearing like? See, I'll tell you a simple logic, okay? The logic is, if you look at the graph should either continuously increase or continuously decrease. For example, if you take sin x, right? Between minus pi by 2 to pi by 2, what happened to the graph? It was continuously increasing. Whereas between, for cos x, between 0 to pi, it was continuously decreasing. So what should happen for tan x? It will continuously increase. It will increase between which two values? It is going to increase between minus pi by 2 to pi by 2. But the question is, are those two pi by 2s included or not? Because they are not generating a finite output. So they should not be a part of the domain. So it will be an open bracket minus pi by 2 to pi by 2. And what is going to be the range of this codomain? So it becomes real number. So what will be the F inverse domain and range? F inverse is R2 minus pi by 2 to pi by 2. Is that clear? Right. Similarly, what will happen for cosecant x? So y is equal to cosecant x. So generally it is defined from where to where? F is mapped from, you guys think and tell me. Is there any value of x that you substitute in cosecant will give you infinity? So whenever you substitute the value, cosecant x is 1 by sin x. Wherever sin is going to give you a 0, cosecant will give you infinity. Correct? So where all will sin give you 0? It will give you zeros at n pi. So you can substitute any real number that you want except n pi where n belongs to z. Accept it. And what is going to be the range for it? This is what the tricky part is. So whatever is the domain, so whatever is the range of sin x will become an exclusion in the case of cosecant. Why? Because they are reciprocals of each other. So sin will always generate a value between -1 to 1, which are fractional values. Correct? A fractional value 0, half, 1 by 2, root 3 by 2, everything is a fractional value except 1 and 1. What will happen to cosecant? Fractional in the sense, it is, I'm saying that those are the values less than 1 or -1. That is what I meant. Whereas in the case of cosecant x, what will happen? It will generate all the values above +1 or below -1. So f is a function mapped from real numbers to n, real numbers except n pi, where n belongs to z, to -infinity to -1, union 1 to infinity. Now tell me where should I use closed bracket and open bracket? Infinity is open, -1 is closed. -1 varume. Sin minus pi by 2. Sin of minus pi by 2 and cosecant minus pi by 2 have the same output. Only the reciprocal, what are you not supposed to? Actually, what is it? It's a rational function. Right? For a rational function, what should not be equal to 0? The denominator should not be equal to 0. So denominator is 0 at n pi. Other than eliminate paniyachu. Okay. When that is going to be the scenario, you substitute any value in the real numbers except n pi, it will always give you a finite value. In that finite value, you will always have -1 and 1 also included. Think about it. Okay. So how is the graph going to look like? So this is the restricted domain and range, correct? So how will the graph look like, guys? So x is equal to 0. So yeah, x is equal to 0. What will happen? Cosecant x will generate, x is 0. Cosecant will generate infinity. So where will the graph start from? Infinity. Then it will keep decreasing till what value? So it will keep decreasing till you reach out to the value of pi by 2. At pi by 2, what will get generated? You will get 1. After you cross pi by 2, the graph will again start increasing and it goes till infinity. At this point, what is this? What is this coordinate? It is pi. Other than you only told no x r minus n pi. So n pi na 0, pi, 2 pi, everything keeps coming. And between pi and 2 pi, what is going to happen? So if you substitute a value greater than pi na which quadrant? Third quadrant. Third quadrant is sign is positive or negative? Negative. So what will happen? The graph will start from -infinity. So -infinity, then the graph will increase and it will go something like this. What is this point? 3 pi by 2. What will be the corresponding point here? -1. Now, Is this a one-to-one function? This is a one-to-one function is what my question is. Answer is no. Right. Similarly, I need to understand what is happening on the left-hand side also. Sharia. So if I take this to be minus 5. Now tell me how is the graph going to be? Downward. Huh? So you are trying to say this kind of a graph will come on the left-hand side. Think about it. You think and tell me, I'll give you time. Yes. So how did you find it out? Okay. Sine of minus x. Perfect. Very good. Because sine of minus x is minus sin x. It's an odd function, right? So when this is the scenario, then you will have a graph like this, right? I made a mistake, sorry. The graph will look something like this. Correct? Again, if you see, I need to restrict its domain to make it a one-to-one function. So how do I restrict its domain? Or restrict the domain minus pi by 2 to f is mapped from, correct only, minus pi by 2 to plus pi by 2. Isn't it the same as that of sin x? Minus pi by 2 to pi by 2. And what is going to be the output? Output another. Minus infinity to minus 1 union 1 to infinity. If I'm not wrong, in your textbook, they would have given something like this. R minus of minus 1 to 1. Yes. They gave open interval. Yeah. Because 1 and 1 are included. They gave it something like this. This and the above mean this. Okay. You have to bear with me for 10 more minutes because I need to explain this concept to solve the problems. Problems are very simple. Actually, they are not this complicated. But you need to understand the theory to solve it. Seriya? 10 to 15 more minutes, things will become simple. See, you yourself can solve it. Either you can breathe. Right? So what will be the inverse of it? So minus infinity to minus 1 union 1 to infinity map to minus pi by 2 to pi by 2. So what you can do is whatever values I'm writing here, prepare a table now itself. Okay. So prepare a table. I'll tell you how to do it. So put the serial number here. Write f of x, domain, range, and f inverse x, domain, range. Okay. So first one, you took sin x, no domain is. So when I say domain here, I'm talking about restricted domain. So what is the restricted domain? Range is minus 1 to 1. So f inverse is minus 1 to 1. Sorry, sin inverse x. Minus 1 to 1 union, minus pi by 2 to pi by 2. Okay. Second, what about cos x, guys? Same. Sorry. 0 to pi and range is minus 1 to 1. Cos inverse x is minus 1 to 1 and this is going to be 0 to 2. Accepted. Third, tan x. Tell me. Restricted domain is between minus pi by 2 to pi by 2. And what is the restricted range? There is no restricted range. It is from minus infinity to infinity. Then what about tan inverse x? Minus infinity to infinity. If you substitute any value between minus infinity to infinity in tan inverse, what will be the output value that will get generated? Minus pi by 2 to pi by 2 is what will get generated. Okay, fourth. We saw cosecant. So for cosecant x, again, what is the restricted domain? there is a small correction there. When talking, I didn't observe. So minus pi by 2 is correct. Between minus pi by 2 to pi by 2, there is a point of discontinuity. So you should remove that 0. So minus pi by 2 to pi by 2, minus pi by 2 to pi by 2, minus 0. Then what is going to be the restricted range? So you will get the value between minus infinity to minus 1, union 1 to infinity. Okay. Now, for cosecant inverse x, what will happen? This will go and sit here. This will go and sit here. The domain and range needs to get swapped. Right? You'll understand why you're doing all these things once you start doing problems. Okay. So till here, I'm assuming that concepts are clear. Right? You're able to understand, right? Why we are writing such values. Now, do for secant x and cot x. Take 2 minutes time. Write it. So leave some space below the table. Right in the next page. Students who are online, if you have any doubt, let me right. So by default, the function will be defined from R to R. So y is equal to secant x. Okay. Secant x another 1 by cos x. Check for the values where cos x will give you 0. Cos x, wherever it is giving you 0, secant x will give you infinity. And the values are take it from the domain. Remove from the domain. Y is equal to secant x. It will be 1 divided by cos x. Right? So, x, what can you substitute? X belongs to. So I'm not talking about restricted domain. Restricted bundle. I'm talking about the basic domain of secant x. X belongs to, you can substitute any real number. Because that's what cos x tells us. So cos x, you can substitute any real number. But there is a point where cos x will generate 0. Correct? When cos x is generating 0, secant x will generate infinity. So in the place of x, you can substitute any real value except the place where cos is generating 0. And the cos generate 1. You have learned about general equations of trigonometric functions. So it will be 2n plus 1 pi by 2, where n belongs to z. Correct? Are you able to understand this? Then what will be the output values you will get? It is the same as that of cosecant x. See, because if you see the domain range of sin x and cos x, aren't they the same? Then what will be the range of the reciprocals? They'll be the same. So it will be between minus infinity to minus 1, union 1 to infinity. Correct? Now this is the actual domain. Now we need to restrict it. See, because it will not be a one-to-one function. Let's try and see. So if I take the graph, x is equal to 0. What is the value of y for secant x? X is 0 on quota. What will be the value of secant? 1 now. So it will be 1 here. Then is it going to decrease or increase? So what will happen? At x is equal to pi by 2, what will happen? It will be infinity. But decrease it should go in the up. Is you told increase? Okay. Increase is right. So it goes in the upward direction and then it will start decreasing again. Sharia. Oh, sorry. It goes like this. At x is equal to pi by 2, it goes like this. Accepted. What will happen on the left hand side? It will be symmetric. Then what is this value? Minus pi by 2. Is that clear? Right. Then what will happen between pi by 2 to pi? Pi by 2 to pi homeward, what will happen? It will be a downward, right? So where will it start? It will be at -1. So the least value that you can get is here. So it will start here and it will be something in this way. Right. Right. Now you restrict the domain and tell me. So F map from 0 to pi minus. If I do this, then it will become a. If I get the values from 0 to pi minus pi by 2, it becomes a one-to-one function. Now, how to make it an onto function? Onto function, still the range is the same. Minus infinity to -1, union 1 to infinity. Okay, then what will be the range of inverse? Minus infinity to -1, union 1 to infinity. This gives you 0 to pi except pi by 2. Sharia? Conceptually, you are able to understand. Similarly, the last function that is left out is cot x. So cotangent, right? So include this in your table under secant x. So y is equal to cot x. So y is equal to cot x is cos x divided by sin x. So you need to eliminate all those values from the domain. So f is a function map from real numbers except r minus n pi, where n belongs to z. So what will be the range? The range is still minus infinity to infinity. It is going to be real number system. Okay, minus infinity to infinity. Right. Now, what is going to be the restricted domain for it? If how is the graph for this going to look like? Can you tell me what is cot 0? Cot 0 is sin 0. Sin 0 is plus infinity. Then what will happen? The graph will decrease. And what is cos pi by 2? Sorry, cot pi by 2. Cot pi by 2 is cos pi by 2 by sin pi by 2. Cos pi by 2 is 0. Sin pi by 2 is 1. 0 by 1 is a 0. So it will touch here and it will become something like this. So this will be the graph. So this is 0. This is going to be pi. Again, the graph will look something like this. Does it make sense? So between pi to 2 pi. So this will be 3 pi by 2. This one the pi by 2. Okay. Now tell me what should be the restricted domain. F is a function. Look at the graph carefully. I told you graph should be continuously decreasing. So f is mapped from 0 to pi, but with open interval. Like you cannot take those values, which leads to the value of minus infinity to infinity. So what will be the value of f inverse? Minus infinity to infinity, 0 to pi. Means you can substitute any value between minus infinity to infinity. You will get the values between open interval 0 to pi. Okay. Now let's try to understand why we are doing all this. As I told you, this theory is slightly tough, but problems are very easy. So did you all prepare the table? I think you would have finished for 4 functions, right? The last 2 also included. No? To solve the problems. So in your textbook, they have given R, no. R and block letters is the same as minus infinity to infinity. Both mean the same. Okay, I hope there is no confusion about that. So capital R is the same as minus infinity to infinity. Have this in your mind. Okay. Now let's see. Listen. Now the question that they are going to see, I'll show you this value. So whatever table, isn't that the table that you have prepared? See, we prepared one side with the basic functions, one side we prepared it with the inverse trigonometric functions. If you see this, it will exactly match with the one that you prepared. So these values are called principal value branches. Okay, what are they? They are the principal value branches. Why we call principal is because principal is generally used for those values which are generated for the first time. So when I started the discussion, I told you why are we restricting the value to minus pi by 2 to pi by 2, not 3 pi by 2 to 5 by 2. Because they are not principal values. So you do it for the first time, those are called as principal value branches. That is why we do this. Principles are something similar to that. Okay. Now, having said this, as I told you, how you are going to apply in this problems. So I told you one thing in the beginning. If you take a trigonometric function, what will be the input you will give to a trigonometric function? You will give an angle. And what will it generate? It will generate a value. So angle will generate a value for trigonometric. If you just swap it, that will be inverse trigonometric. So sine inverse will be having the input as value. You will be finding the corresponding angle for it. That's what the question is. But the only thing that they add is find the principal value. They don't ask you find the value of sine inverse of 1 by root 2. Find the principal value of sine inverse of 1 by root 2 means what is the angle that you are supposed to substitute for the first time so that sine will generate a value of 1 by root 2. That is the meaning. So which one will generate? Sine of how much is 1 by root 2? Pi by 4, 45 degrees. But that's what we need to prove it with some steps. That's where the knowledge of functions comes into picture. Okay, it's the same logic again. So first you will say sine inverse of 1 by root 2, you will call it as y. Sharia. So within the restricted domain, if f is sine x, okay, f inverse is sine inverse x. Okay. Now tell me what will f of f inverse of x be? F of f inverse x now, sine of sine inverse x ever. I told you right in the beginning. If a function is an inverse of another, then the composition of both will generate a value of x. So sine of sine inverse x is x. It is not because sine and sine inverse are getting cancelled. It gives you an identity function. It gives you x. What does this x value belong to? Value. Because the x is coming from sine inverse. Sine inverse, what will you substitute? Value. Okay, that is what you are getting. So the steps that you are supposed to follow, listen to this carefully. This will solve the issue. The question is sine inverse of 1 by root 2, principal value. So first step is assume this to be y. Second step, take the corresponding trigonometric function of whatever is the inverse on both the sides. So since here it is sine inverse, you will consider sine on both the sides. So consider sine inverse of 1 by root 2 is equal to sine y. Okay. So sine of sine inverse of 1 by root 2 is how much? 1 by root 2 is equal to sine y. Now what does y belong to or y is equal to? So can I write sine y is equal to sine pi by 4? But the thing you need to be careful here is you should not write any value outside its restricted domain. That is, you should not write any value outside minus pi by 2 to pi by 2. Yeah. What is your table telling you? When you take that value, 1 by root 2 is the value. When you substitute that value in sine inverse, it should give you a value only between minus pi by 2 to pi by 2. You can ask me a question, sir, sine 5 pi by 4 is also 1 by root 2. But you should not write it. Because question says principal value. So sine y is equal to sine pi by 4. Now y is equal to pi by 4. You can assume. You can think it's a simple problem, but why are we doing all these steps? Minus one of a fraction. At that point, I'll explain it. It's a simple problem only because it is positive. But how will you handle when minus comes? I'll teach you. Right. Tarush, you're able to understand to some extent? Yeah, you can solve this, right? Actually, you? Yeah, forgot your name. Dinesh, no? Yeah, you're able to understand? Some extent. Don't worry, it's simple. By tomorrow, you will get it. Those who are online, I hope you're able to understand, right?
Yes, sir.
Okay. So, as I told you, we'll start with positive values first. Then we'll go to negative values. Then I'll teach you a separate procedure. So, if you see exercise 2.1, question number 2, 3, 7, 8 are having positive values. Okay, let's try for it. 2, 3, 7, 8. 7, 8, 2, 3, 7, 8. Do them, no? Same logic. So, who can tell me? Who can tell me the steps? Cos inverse of root 3 by 2. How should I write it? Assume it to be y. So what function should I consider on both the sides? Cos. So consider cos on both the sides. Cos of cos inverse of root 3 by 2 is equal to cos y. Correct? So cos of cos inverse of root 3 by 2 is root 3 by 2. That value itself is equal to cos y. So cos of what value is it root 3 by 2? For the first time, it is
Pi by 6.
Pi by 6. So cos pi by 6, that is 30 degrees, is equal to cos pi. Remember, the arguments are always written only in terms of radians. Don't write them in terms of degrees. Okay. So y is equal to how much? That is the answer over there. Okay. So by looking at itself, looking at the question itself, you can say, but you need to show these steps. Sharia. You suppose the same thing is applied in physics. You can directly write the answer as pi by 6. Nobody will ask you. Whereas here, you need to show the steps. Sharia. Even before we solve the question, can you tell me cosecant inverse 2? What is the answer? Next one, third one. Cosecant inverse 2. Pi by 6. Right. So how will you get it? So third one, cosecant inverse 2, you will assume to be y. What should I consider on both the sides? Cosecant. So cosecant of cosecant inverse 2 is equal to cosecant y. So cosecant of cosecant inverse 2 is how much? 2. See, always one more important thing. If the question is cosecant inverse 0, the question is cosecant inverse 0. It is not in the domain of theta. So what is the domain of cosecant inverse? You can substitute any real numbers. You should remove the value between -1 to 1. Where it is 0 for? Somewhere between -2. So that value doesn't have inverse of cosecant itself. You to understand. So that is one more thing you need to make a check of. So cosecant of cosecant inverse 2 is equal to cosecant y. So how can I write this 2 as? Suppose you don't know cosecant table, what you can do is you can convert it to sine. So 1 by 2 is equal to sine y. Correct? Because cosecant y is 1 by sine y. So 1 by 2 is sine y. 1 by 2 is how much? Sine pi by 6 is equal to sine pi. My charge got over. Try solving it. Sine pi by 6 is equal to sine by y out. Pi by 6. Simple, huh? So the table that you prepared is what you need to memorize. Okay. We get it with practice. That's a different story. But you have to practice properly. Sharia. So sine pi by 6 is equal to sine by upper y on the pi by 6. Okay. Can we do the next two problems faster? So secant inverse 2 by 3. Answer. Pi by 6. I'm leaving it to you. You can do it. Okay. That is pi by 6. Cot inverse of root 3. Pi by 6. See, all the answers are the same. Right. So for positive values, we are clear. Now, how to deal with negative values? Shall we try that? Listen. I'm assuming everyone is clear. Yes. Where is music coming from? You have to hear that. Music is okay. See, let's try this one. Cot inverse of -1 divided by √3. Okay. Cot inverse of -1 divided by √3. I'll assume it to be 1. What should we take on both the sides? I'll take cot on both the sides. Cot inverse of -1 divided by √3 is equal to cot y. So cot inverse of -1 by √3 is -1 by √3 is equal to cot y. Now comes an important question. So what is the restricted domain of cot? Restricted domain of cot, not cot inverse. It is 0 to pi. So you need to find so that is telling us that the value of y is going to lie somewhere between 0 to pi. That is the principal value. But unfortunately, you have a negative sign here. So generally, in the first quadrant, see, you break it like this, okay, 0 to pi, or if you take the other limits, it will be -pi by 2 to pi by 2. One simple technique, look at the table for 2 minutes. So if you look at the table, there will be 3 inverse trigonometric functions which have the domain between -pi by 2 pi by 2. What are they? Sine inverse, tan inverse, and cosecant inverse. There will be 3 functions exactly having between 0 to pi. What are they? Cos inverse, secant inverse, and cot inverse. So cot inverse lies somewhere between 0 to pi. Now think of this fact. Okay, 0 to pi, 0 to pi by 2 is first quadrant, pi by 2 to pi is second quadrant. In the first quadrant, all trigonometric functions are positive. In the second quadrant, how will you write the angles as? Generally, what is the general structure of, you write it as pi minus something, correct? So what you're supposed to do is, had this been a positive value, then what value of cot will give you 1 by √3 for the first time? Pi by 3, right? So this, can I write it as cot of pi minus pi by 3? Why did I write it as pi minus pi by 3? Because I understood that negative value is telling me that it is happening only in the second quadrant. In second quadrant, I know the format of angle is pi minus alpha for those functions whose restricted domains are between 0 to pi. So this is the same logic you need to apply for cos inverse and where function secant inverse. So wherever cot inverse, secant inverse, or cos inverse are having negative values, you write pi minus the acute angle. So first find the acute angle, then write pi minus pi by 3. So it is going to be cot y. So this is 2 pi by 3. Appa y another 2 pi by 3. Is 2 pi by 3 lying between 0 to pi? Yes, it is. So that's the answer. Am I clear? Or is there any confusion? Is there any point you want me to repeat? Understood, right? Okay. See, this exercise, we are solving it like this, but with the future exercises, you can solve them even in a simpler form. Okay, they become simple. Only 2.2 will make it easy. Okay. Now see for sine inverse of -half. So sine inverse, what is the restricted domain? -pi by 2 to pi by 2. So whenever you have -pi by 2 to pi by 2, right? Whenever you have these kind of functions, that is sine inverse, tan inverse, and cosecant inverse. First, find the acute angle and put a minus. Why? Because -pi by 2 to pi by 2, break it. -pi by 2 to 0, which quadrant? -pi by 2 to 0, fourth quadrant. And 0 to pi by 2, first quadrant. Since sine inverse of -half is there, where will the angle lie? Will it be the fourth quadrant or the first quadrant? Fourth quadrant. Another, find the acute angle. Just put a minus sign before it. Your job is done. So yeah. So how to solve that? I'll show you the steps. Sine inverse of -half is equal to y. What should I take on both the sides? Sine inverse of -half is equal to sine y. So -half is equal to sine y. So this will become equal to minus of, or I will write it like this, sine of, 1 minute, my sweat. So this will be sine of minus, what is the acute angle for which you will get half? Pi by 6. So this is sine minus pi by 6 is equal to sine y. So y is equal to minus pi by 6. Because minus pi by 6 lies between minus pi by 2 and plus pi. Purida. Negative, but it is not there in the principal domain. It is not restricted. So if you write pi plus 10 now, if you go beyond pi by 2 and the value 8, so then it will not be principal value. That is why read the question carefully. They told find the principal value. They didn't ask you the values. Principal value than there. Right? So can we take 2 minutes time and complete all the problems? And all in the sense between 10. That's it. So we have finished first, second, third, fourth one. So tan inverse. Tan inverse, what is the restricted domain? Minus pi by 2 to pi by 2. So find the acute angle, put a minus sign. What is the answer? Minus pi by, correct. Minus pi by 3. What about cos inverse of minus half? Cos inverse, what is the restricted domain? 0 to pi line up on no. Pi minus acute angle. So how you find that acute angle? Always find it for positive value, then write pi minus acute angle. So if it is cos inverse half, what will be the acute angle? Dinesh, can you try? So cos inverse half, what would have been the value, principal value? Cos inverse half. Had it been cos inverse half, what would have been the principal value? What value of cos will give you half? Pi by 3. That is 60 degrees. So yeah, you get minus half. So what are you supposed to do? Pi minus pi by 3. So why are we doing pi minus for cos inverse? Because its restricted domain is between 0 to pi, first and second quadrant. Do it. Answer another. I'll consolidate everything and give you an algorithm tomorrow. But if you solve pi minus pi by 3. 2 pi by 3. You wrote minus pi by 3. It is pi minus pi by 3 for cos inverse minus half. So you are able to understand? To some extent, or you are clear? I don't want to leave with doubt. You are not able to understand. What is the problem? When to use pi minus? Look at the table. I asked you to write a table. Look at the table under inverse functions. So under inverse function, what are the three functions having the domain between minus pi by 2 pi by 2? Sine inverse, tan inverse, cosecant inverse. So if the question starts with a negative value for sine inverse, tan inverse or cosecant inverse, then you write the acute angle and put a minus sign. If the question starts with cos inverse, secant inverse or cot inverse, pi minus acute angle. So this problem is cos inverse of minus half. So pi minus acute angle 2 pi by 3. What about tan inverse minus 1? Minus pi by 4. That's it. What about cos inverse of minus 1 by root 2? Cos inverse, now what are you supposed to do? Pi minus 1 by root 2. Wherever cos is giving you 1 by root 2. Pi minus pi by 4. 3 pi by 4. What about, we solved cosecant inverse minus root 2. So cosecant inverse minus root 2 another. Minus 5. How many of you are not clear? Be honest. So that I can help you. How many of you are not clear? You're not able to solve fast. What is not clear? You can tell me the problem, I can help you. Negative part more confusing. Others are clear. Right? Shubham, you're clear? Negative. Honest. You're clear, right? You're clear? How about you, Harshida? You're clear, right? You can solve any problem, Vaishnavi? You're clear, right? Okay. So those who are clear, you can leave. Those who are not clear, just wait for 5 minutes. We'll close the issue. Okay. Similarly, those who are online, is there anything that is not clear?
Sir, I'm clear, sir.
You're clear. 1 minute. Who told? Who was that?
Sir,
Nitin, huh?
Nitin Anand.
Nitin Anand clear. What about Arvind? You're clear? Hamsini, you're clear?
Yes, sir.
Harini, you're clear? Okay. Harini, you're clear? Okay. We'll discuss now. Yeah. Okay, those who are clear, you can leave. Okay, leave the session.